Ramanujan for G is now available on the Google Play Store. Try it out for free.
So today for the permutations and the combination, we'll start with the selection of selections from identical objects. Let me write selection from identical objects. Okay. So first thing, the number of combination of n identical things taking r at a time is 1. Let me write the number of combination of n identical things taking r, meaning r less than equals to n at a time, is 1. Okay. Next is the number of ways of selecting r things out of n alike things is n plus 1. The number of ways of selecting r things out of n alike things is n plus 1. That is right. Next, the number of ways to select some or all out of P plus Q plus R things, where P are alike of the first kind, Q are alike of the second kind, R is the alike of the third kind. That is equals to P plus 1, Q plus 1, R plus 1 minus of 1. So let me write the number of ways to select some or all out of P plus Q plus R things where P are alike of first kind, Q are alike of second kind, and R of alike of third kind. That is P plus 1, Q plus 1, R plus 1 minus of 1. Okay, now let's look at example. So there are n different books and and p copies of each in a library. So the number of ways, so the number of ways in which one or more than one book can be selected as. So options are given p to the power n plus 1. Second is p plus 1 power n minus 1. Third, p plus 1 power n minus p. Fourth is p to the power n. Okay. So first we will write the total cases. So total cases will be p plus 1 if selected or not. So required number of ways, that is p plus 1, p plus 1 and goes up to n terms minus 1, that is p plus 1 to the power n minus 1, right? So meaning option 2 is the correct answer. Okay, next example. A bag contains a bag contains 3 1 rupee coin, 3 1 rupees coin, 4 50 paise coins, 4 50 paise coin and 5 10 paise coins. So how many selections of money can be formed by taking at least one coin from bag? It is 120, second is 60, third is 119 and fourth is 59, 60. So let's solve. So here three things of first kind, right? And 4 things of second kind and 4 things of third kind. So total number of selections, total number of selection will be based on p plus 1, q plus 1, r plus 1, minus 1, right? So it will be 3 plus 1, 4 plus 1, 5 plus 1, minus 1. That is 4 into 5, that is 20. 20 into 6, 120, minus 1, that is 1119. So option 3 is the correct answer. Next is selection when both identical and distinct objects are present. Okay, so like if out of p plus q plus r plus t things, p are alike of one kind, q are alike of second kind, r are alike of third kind, and t are different. T are different. Then total number of combinations is p plus 1, q plus 1, r plus 1, 2 to the power t minus 1. Okay, so this formula you need to remember when t are different. P plus 1, q plus 1, r plus 1, t to the power 2 to the power t minus of 1. Next is division and distribution of objects. Okay, so here the number of ways, the number of ways in which m plus n different things can be divided into two groups which contain m and n things respectively. So that is m plus n cm ncm, that is m factorial. So m is not equals to n. There are some particular cases. Let me write particular cases. So like when m is equals to n, So total number of combination will be 2m factorial divided by m factorial square when order of group is taken. Similarly, 2m factorial 2 factorial m factorial whole square when order of group is not taken. Okay, so these are two particular cases when m is equals to n. Next thing is the number of ways in which m plus n plus p different things can be divided into three groups which contain m and p things, meaning m plus n plus p cm into n plus p cp into c pcp, that will become m n p factorial divided by m factorial p factorial, that is not equals to m, not equals to p. So for particular cases when m is equals to n is equals to p, so that will first will become 3m factorial divided by m factorial cube when group taken. Group consider, we can write group consider. Similarly, 3m factorial divided by 3 factorial m factorial cube, that is group not consider. Okay, copy this first. Next is total number of ways to divide an identical things among r person is. So that will be n plus r minus 1 c of r minus 1. So here we can write total number of ways to divide and identical things among r persons, so that each gets at least one is, that is n minus 1 c of r minus 1. Okay, so with this we'll wind up the permutations lectures here. Okay, next class we'll take examples. Okay. Okay, so thank you guys, we'll see you in the next class.